With this example, it's asking you to sketch this function y is equal to x plus 1 all squared, 1 minus x. Now, with a bit more experience, you will look at that and realise it's actually a cubic, because we'd have x to the power 3 as our highest power, and any time x to the power 3 we call it a cubic. We know it's more than the simple cubic because there'd be some x squared terms and some x terms, so it's going to be a bit more complicated. Also, with a bit more experience, this x would be a positive x squared times a negative x would actually make it overall a negative x cubed. And if we've got a negative x cubed, then as x gets really, really big, the graph is getting very, very negative. So we actually have a cubic that should look like that. So it comes in from the positive and it goes away, becoming very negative as x is getting bigger. Let's see now if, just using our straight algebraic understanding of graphs, equates to these other skills we've learned about sketching graphs. And we're focusing in this exercise on the x-intercepts. They occur when y is 0. So we're going to solve 0 is equal to that. And it's nice that they gave it to you in factored form, so we don't have to factorise it. Thinking about how we'll get a 0, well, this bracket could be 0, and for that bracket there to be a 0, we'd have to have x is minus 1, or this bracket might be 0 and x is 1. So we just have two possible intercepts. You can see I've put those into our table here at minus 1 and 1. Now, the idea of the sign aspect to this this exercise is that we're going to look at the sign of the functions around these x-intercepts. So let's have a look at just before that x-intercept, in between those two, and we'll just stick with nice whole numbers, and maybe to the right, and see. We're just interested in the sign of the y value. So you can see here, I've set out when x is minus 2, what would y be? I'm subbing into here, minus 2 plus 1 all squared. Now anything all squared is a positive. And really, ultimately, I'm only interested in the sign. Why? So that I can get a sense of where the graph is at minus 2. Is it above the axis? Is it below the axis? And likewise at 0 and at 2. I'll just fill this in. We know that is on the axis there, and whoops, it's on the axis here at 1. And this is the x-axis. I'll ignore that dot there and hope you can too. So, so we know that, where are we? This is going to be a positive. Any bracket squared will be a positive answer. And 1 subtract negative 2 is also positive. So a positive and a positive would give me at x is 2, we've got a positive y function value. So it's up here. So for this much, we can see we're coming down. Now, I suppose, do we go on down? Do we turn and go back up? What actually is going to happen, we can find out by looking at the sign of the function value or the y value when x is 0. So you can see here I've done when x is 0, I've subbed in 0, 0 plus 1, all squared, and 1 minus 0. Now anything squared is positive times 1 is also positive, and a positive times a positive, we've gone positive again. So at 0, the function is positive. The y values are above the x-axis. So we must turn at this point and come up. and then we know we come back down because there's another x-intercept over here at 1. Then we're left to investigate what's going on when x is 2. So sub that into here. So 2 plus 1 all squared, 1 minus 2. Any bracket squared will be positive, times 1 subtract 2 is a negative, and a positive times a negative is a negative. So the y value is negative. So, and so we have, this is a negative, and at 2 it's some negative value, and we know it doesn't come back because there are no more turning points. Well, actually, I suppose we don't, strictly speaking. It could come back and run along there, which is a possibility without it ever getting to the x-axis and creating an x-intercept. But that's why I said, there's going to be some skills that you'll learn about that will help you with curve sketching in much later chapter, which I'm sure you're going to rely on much more heavily, and they'll be your go-to for drawing a graph, sketching a function in the future, rather than this particular one. It's good enough for now to know that would be the graph of this particular function. 2 says solve where is this function greater than 0. Greater than 0 is above the x-axis. Now, greater than, so it can't be on the x-axis. So we've got when x is less than -1, it was definitely above, but not equal, because at equal to -1, it's actually it's equal to 0. It was on the axis. The other regions where it's been positive is when x was less than 1 and greater than -1. So you can write your answers. So that gives us this region in here. And again, it's never equal at -1, and it's never not equal at +1. Okay, I'll stop the video there. Hopefully you're right to do exercise 3B.